So hi, this is the video for my HD project presentation. So at the very first, I would like to introduce the SD module first. This is the component that I originally planned to use in my project. The main function of the SD card is to store data. I initially hoped to use it in my circuits to record the environmental data such as temperature, humidity. This would allow me to check the growth conditions of the plants over time and provide more efficient care. But however, after connecting to the arduino here, I encountered a huge issue that caused the DHT22 sensor to output NaN value. NaN represents not a number and results in the LCD screen here to display a garbled text. So this was due to insufficient voltage after doing a lot of research. So then the SD module consumes a certain amount of current during operation, and especially when reading and writing data, since the Arduino has limited power up to 5 voltages. So connecting this module leads to insufficient current distribution, which in turn affects the normal operations of other components. Therefore, I have to replace it with other two extra functionality, which is store the data in serial monitor, which I will show you here in the Linux using screen commands. And the other one is I set the countdown on my screen, LCD screen, and you can see in the screen the left corner that the time is counting not only humidity, temperature, and soil sensor this time, and I will introduce it later. So then I'm going to introduce these components of my project right now. So the first one is the Arduino board here. So this is the core control board of my whole project. So it's responsible for processing and controlling all connected sensors and components. It receives data from sensors and executes corresponding logic to ensure the system operates smoothly. And the second one is the LCD screen here. It used to display real-time data, environmental data. Users, which is me, can conveniently assess the current status of the plant growth conditions through clear text. And the next one is DHT22 sensors. This is to measure the temperature and humidity in the air, and its high accuracy and fast response make it ideal for monitoring the conditions. So you can see that there are two registers here. The first one here is on the left is connecting to the LCD screen, and here this one, orange one, is connecting to the DHT22. So their purpose is to prevent excessive current from flowing into the components, which could otherwise damage them. And the next one is the soil sensor. This is used to measure the soil moisture in real time, ensuring that the plant roots have enough water. It helps prevent damage to plants due to drought and keep it wet. So the last one here, you can see I have a buzzer in here, and this will sound an alarm when having extreme conditions such as too high of temperature or too low of soil moisture, alerting the users, which is me, to take action of it. This audible alert is crucial as it allows me to monitor the plant status without constantly checking the displays. So this is all about introducing the components. Let's look at how to control this to the board. So the LCD pins are connected to the board, to the Arduino board in digital pin 12, 11, 5, 4, and 3, 2, and to facilitate data transformation and display information in the screen. Here you can see it. And the DHT22 is connected to pin 10, responsible for reading the temperature and humidity of the air, and the soil moisture is connecting to an analog input A0. You can see it in here. Yeah, this one. Allowing the real-time sensor real-time readings of the soil moisture to provide necessary water for the plants. And the last one, the buzzer, is connecting to the pin 6 here, which will respond turning it on or off based on environmental conditions. So right now the soil moisture is in a normal condition, which is I set less than 500 is the normal condition. So we can see it in here. Yeah, here. If the soil moisture is bigger than 500, it will trigger alert. Air temperature bigger than 40 and humidity less than 50, because those are the conditions in the air. It's very difficult for me to control it, so I will control the soil moisture to show you the differences, to show you how the buzzer responds. So now we can see that it's the soil moisture is around 200, so it's less than 500, so that the buzzer is off right now. But when I put it into a drier size, like yeah, it's over 500 right now, so the buzzer is on. I'm not sure if you can hear the voice, so yeah, you can hear that it's actually tick 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 is alerting, but it's alerting me that this is beyond the safe conditions. So yeah, that's all for the project. So basically just I use DHT22 sensors, soil moisture sensors, and LCD screen to display all the environmental data. And you can see here at the left corner there is a time counting. This is, I set it to 10 minutes. This is used to remind me when to water it. So let's also I can see that I'm not only can check the outputs in LCD screen, but also can check it in Linux by using the commands screen. Yeah, def tty acmo is my output, and yeah, and you can see that I can also check it in here, but after I remove it, and the soil moisture becomes 0 because I remove, and I put it into again. Yeah, it's have a normal sensor output. So basically, this is my HD projects by by setting up a real-time monitor system, and I can check all the data in the LCD screen with a countdown. So thank you for watching, and I also have the explanation why I don't use it in my final project due to the some power issue. So I'm very unlucky and set for this. So yeah, thank you for watching.